Hello everyone, this is Muhammad Javed, lecturer Mathematics International Maritime College. Today's video will be explaining the concept of eigenvalues, whose subtopics trivial and non-trivial solutions comes first. Here is a system of simultaneous equations. If we solve this system, we get x equals 0, y equals 0. We can do this by Gaussian elimination, or they are simple equations, so we can also solve them. For example, if we multiply by simple algebra, I am doing it elimination method. So if we multiply this with 2, so it will become 10x minus 6y equals 0. We get this equation by multiplying, and here it is already 10, so I wanted to cancel x, that is why I multiplied the first equation with 2 equals 0, and if we subtract them, here it is plus, minus and plus. They are cancelled, and here will be minus 4y equals 0. So if we divide this by minus 4, so answer comes out 0, which is this answer. And if we plug this y equals 0 in this second equation or in the first equation, we can get x value. Say we plug in it in the second equation, which is 10. You can also plug this into the first equation, minus 2 into 0 equals 0, and easily we can get x equals 0. So we call this trivial solution, which is a unique solution, okay, for this system of linear equation, simultaneous equation, okay. Well, now I'm taking another set of simultaneous equation to explain the non-trivial solution, and let that be 5x minus 3y. So I made little difference here, if you see. So it is different from the first system of linear equation. Now if you see these two equations, here is a little difference, and the difference is that actually the second equation is multiple of the first equation, and it will be 3y equal 0. And if we simplify it, it comes 5x minus 3y equals 0. So see, The second equation gives us this, which is similar to the first equation. So it means that technically we are dealing one equation. They are not two equations. They are technically one equation. They are two equations, but we are dealing with one equation at the moment. So I repeated the same procedure as I explained with my handwriting. Okay, and so look, this is again the first equation, and now this is one equation and two variables. So we cannot find a unique solution, and if we want to find one of the variable from it, suppose I'm going to find x from it. So 5x equals 3y, and if I take first 3 by 5y, and if I plug in for y equals t, so this is x value and y we supposed t. We can solve this one equation this way. So x comes 3 by 5 and let y equals t, what I explained with that written. Then x becomes 3 by 5t. Trivial solution, x equals 0 and y equals 0. This is trivial solution. This is called trivial solution for the first system, and non-trivial solutions is this one. And if you could remember, in the system of a linear equation, we used to say there are infinite number of solutions. So it is I think I forgot here t. So something not new. When you get unique solution in this system of equation, ax equal 0, then we call it trivial solution. And when there are infinite number of solutions, we call them non-trivial solution in this. Okay. Here, before this in matrices, ax equals p, if you could remember, there were three types of solution. One was unique. Number two were infinite number of solution. I explained this early in the previous video about that. And number three, no solution. Okay, it was actually three matrices. We call it A, this one x, and equals this one b. So two simultaneous equation was there. But in this case, this matrix will be A, this will be x, y, and here 0. So this matrix will be actually 0 in this case the solutions are named as trivial and non-trivial. Sample. Let's go to I think example. Okay, key points. So we need to keep these key points with us for ax equals 0. I mentioned that it means a or b1 a2 b2 x y equals 0 0. When we were doing with Kramer rule and when we were doing with Gauss elimination, the system had A1, A2, B1, B2, and then X, Y equals K1 and K2. So see the difference in both the system. So in eigenvalues for trivial and non-trivial solution, metric system will be like this, which means okay, a1 b1 a2 b2. Oops, this is supposed to be b1. Anyway, if you 1 b2 are difficult, so simply a b c and d, and I think this book is using here a b c d. So let's do it, make it little difference with the previous topics of Kramer rule and Gaussian elimination. Now we should keep this point with us, that if the determinant value, this matrix value in this system is 0, then there will be non-trivial solution. Non-trivial solution means where you select where y equals t or x equals t, and then you get, for if you select x equals 2, then y value will be in term of t some value, and here x value is, so which one you are taking t, the other one will be according to that. So in this system again, ax equals 0, which is this. If the determinant of this matrix is 0, then we get non-trivial solutions. If the determinant is not 0, determinant value is not 0, so it has got one unique solution, which we called in this system trivial solution. Example 4.1, page 606. Decide which system has non-trivial solution. So there are two systems given in this example, AB. So let's see. if you see, this equation is different from this one, and in this case if we take 3 common, so x plus 2y equals 0, which is exactly the first equation. So in this case, this is of course non-trivial solution, and here there are 2 equations. So here in case B we are dealing with one equation actually, which is x plus 2y equals 0, x plus 2y equals 0. So we are dealing with one equation, so here the solution will be non-trivial. This equation clear difference between the coefficients, so we will get trivial answers. So first of all, a matrix form, and matrix form is we study in introduction. The system should be Ax equal 0 or O matrix or null matrix. Okay, this is our A. Now we go for its determinant. So we determinant, I explained this very well in Kramer rule. Anyway, multiply these two, 12 minus multiply these two minus 2, so 12 plus 2, 14 is coming, I think. Oh, 10 minus 10 coming, which is not 0. When it is not 0, then it has a trivial solution. Trivial. Okay. In part B is we see this. Though I explained without matrices the relation between of two equations, now let's see with the help of matrices. So if this is A here, and diagonal multiplication of this minus diagonal multiplication of this equals 0. So when it comes 0, we will get non-trivial solution. Non-trivial solution means where you take one variable t and the other will come in terms of that. So non-trivial solution. Now here is an example, and it is about to determine if the system is got trivial solution or non-trivial solution. So here we have a system of simultaneous equations. So first of all, we'll go and this is x equals 0, a matrix, x matrix, and on the right side is null matrix or 0 0 matrix. This is our A matrix. X is x y z as usual. Then to find determinant, if you could remember, I explained very well in the Kramer rule. Multiply these 3, then these 3, and this diagonal, then minus diagonal 3 to 1, diagonal 1 to 8. So determinant is coming 0. So here this diagonal give us the first diagonal from left to down is coming 18. The other diagonal minus 1, 2, 4 is coming, minus 8. Then the third diagonal 1, 1, 1 is of course 1. Then we put a square bracket and minus. Now we start from this diagonal right to the left bottom, so minus 3 is coming. Okay, now this diagonal 3, 2, 1 is coming 6, and this is plus 6. And this diagonal is 1, 2, 4 is 8. Well, these three I think will give us 11, and then minus 3 plus 6 is plus 3, and then plus 8, so 11, which is 0. So it's equal to 0 when the determinant equals to 0. In the key points in the previous slides told us that if the determinant is 0, there will be non-trivial solutions. Okay, now let's take another example, and I think it's for trivial solution. Determinant will be becoming non-zero. We are going to solve it. Yes, and I hope there will be no question about. So if we split the left side, the right side, so the left side gives us two matrices. I'm doing here a space here, so it is like 3, 1 and 5. Minus 1, 2 and minus 1 again, 1, 2, 3, and x, y and z equals 3, 0, 0, 0 and 0. Okay, we call it A. This matrix is X, and n equals, this matrix is capital O. So AX, I think no more confusion over there. Okay, A. Now we are going to solve a determinant. So with the same way, if we multiply this diagonal elements, then this, minus and this three diagonal, the answer will be something not equal to 0. So when it is not equal to 0, it means it has a trivial solution. It has a kind of unique solution, one solution. As we learned in Gaussian elimination. Okay, is exercise has got, I think, this one 2 by 2 matrix, 2 by 2, all 2 by 2, 2 by 2, and here little challenge is given. So if we shift this minus 2x to the left side, it will become minus 2x plus y equals 0. X and 3y will be shifted to other side, 3y equals 0. Okay. So in first case, a is 1, 3, minus 2 and minus 6, and the determinant will be equals minus 6 into 1 is minus 6. Then we write minus, and then 2 and minus 2 and 3 is coming minus 6 as well. So answer is coming 0. So when answer is coming 0, it means this has got non-trivial solution. Well, now I think you will be at expert level. So 2 3s are 6 minus 9 ones are 9 equals minus 3, which is not equal to 0. When it is not equal to 0, it means it has a trivial solution. So it has a trivial solution. The first one here, non-trivial solution. Okay, you can also check this. This is 12 minus 3 and minus 4 is 12, which is coming 0. So it has got also a non-trivial solution. It has non-trivial solutions. Trivial solution is one always, and non-trivial solutions are many. Okay, multiply these two. So if we do it, it comes, I think, minus 4 if you agree, and then minus, and minus 2 and 2 will be again minus 4. Calculator equals 0. So this one has also got non-trivial solution. Okay, try yourself. Now let's come here. The matrix is 1 3 1 2 1 1 minus 1 2, there is no z, so 0. This is our A matrix. Okay, to find its determinant, the first 2 column will be repeated in the 4th column and in the 5th column. 1 1 and 1. Okay, so first we do this column, which gives result 0, plus then we do this column, which comes 4 if we multiply them, and then this column which comes -3, and like this minus. Now this column is 2 3, so 0, sorry, diagonal. Now this diagonal, so 1 2 and 1 is 2, and then the diagonal -1 and 2 1 is -1, it comes 1, and this is come +1, so -1 equals 0. Determinant is 0, so 0 means it has non-trivial solutions. We are not going for solutions, it was just to know whether it has trivial solution or non-trivial solution. Okay, now eigenvalues, some people call it eigenvalues, some eigenvalues, so pronunciation differs. Okay, I will start to explain this with an example. So right side you would have noticed again x is repeated with some number, and the second equation y is coming with some fixed number. We call it lambda. This is a Greek letter. We call it, I think I should spell lambda. In physics we generally use it for frequency, if you could remember. So actually these lambda are called eigenvalue in this kind of system. Well, here A and look, left side we got two matrices, right side we got this matrix. So x or lambda is here, so lambda is taken out common, and the left side they can be two matrices. This is 2 1 3 4 is matrix A actually, and x y are variables, so this is x equals lambda x. X means x y, x matrix means this matrix, capital X, write it little bigger. Okay, done. Oh yes, because okay, I already explained there. Ax, then what we do, we take this to the left side, so minus will come. Now x is a number, x is a matrix, A is a matrix, x is a matrix, keep in mind. Okay, so I'm putting identity matrix. Identity matrix are square matrices of this kind: 1 0 0 1, or 1 0 0 0 1 0 0 0 1. So this kind of matrices look, the diagonal we have 1 1 1 1, we call them identity matrix. So identity matrix is a kind of 1 in matrices. If a number 1 is multiplied with something, any value, the result is same, so identity is like that. Okay, now I'm taking X matrix common from both the terms, and for non-trivial solution is before this, here in the previous questions examples, a x equals 0, so trivial and non-trivial solutions conditions were trivial, non-trivial and trivial condition. The condition of this was the A determinant is not equal and for trivial solution for non-trivial solution it must be, in the previous cases we saw non-trivial solution, it is equal to 0, and this was not equal to 0, then so you can say now this is a matrix A and this is matrix X. So when A was equal to 0, we are getting non-trivial solution. If this whole matrix determinant is 0, so there will be non-trivial solution. So you can compare this situation. Okay. So this matrix is whole is now A matrix. If I write here B, then it will be fine. Okay, but I think understandable. Well, and so if we calculate it in this example, and then we calculate its determinant. Okay, look. So we are going to calculate this A minus lambda I, A minus lambda I at multiply lambda inside, so lambda will be multiplied with each and every number, it's coming this. Now subtraction, so 2 minus lambda, 1 minus 0, corresponding element will be subtracted, and then it's coming for non-trivial solution is we discussed earlier, it will be 0. We solve this, multiply these two and then these two, we will take it equal. Non-trivial solution, all the time this matrix will be equal to or will be taken equal to 0. Now we solve this, it comes out x square minus 6 is factorization. If you are good at factorization algebraic work, then fine, otherwise calculator can help you. And lambda has two values, so we can say these two are the eigenvalues, or they are the eigenvalues. So for in the case of eigenvalue, the system will be like A x equals lambda x. When we solve it for lambda, those values will be called eigenvalues. And for trivial and non-trivial solution, generally x will be equal to 0, so 0 means null matrix. They give us basic concept, and with the help of this we solve this. So trivial and non-trivial concept is here, and then we apply this, and the lambda value will be called eigenvalue. Shall I do it or shall I leave it for you as an example? I think let's go through it quickly. So fine, it is actually a x lambda x, okay, then a x minus lambda x equals 0. If we take out matrix x common, so it will be lambda I is like 1, so when you take x outside, so you will write 1 for that. Then for non-trivial solution, a minus lambda I will be equal to 0. A is 1, 2, 4, 3, and minus lambda I means lambda 0, 0, and lambda. It will come out is lambda 1 minus lambda, 2 minus 0 is 2, 4 minus 0 is 4, and 3 minus lambda. And for non-trivial, this determinant will be equal to 0. This is condition for non-trivial solution, multiplying these two and then solving. So let's see my neat and clean work. Okay, and I hope we will be clear enough. Okay, so solving this, 1 minus multiplying them, and this is condition for non-trivial solution. Okay, and lambda square minus 4 lambda plus 5 equals 0. Solving it for lambda. If you are good at algebra, then fine, otherwise calculator is answer. So I hope no difficulty is here. This is okay, this a minus lambda I equals 0 is called characteristic equation. So I'm going quickly through it. So characteristic equation, so it's not a big deal, the same thing. Characteristic equation mean this thing, a minus lambda I equals 0. This is for you, I think, activity, so you try yourself. Even things are given in the book. Oh, now 3. So before the battery of my computer go into trouble, I do quickly. So a minus look, a minus lambda I you need to, so a is this one, and since this is 3 cross 3 matrix, so lambda 1 0 0 0 0 1 0 0 0 1. So I think clear. Now we are going for determinant, so we will repeat the first two columns here, okay, and then solution. So I'm cleaning it. Okay, so first let's do this diagonal, then this diagonal, and then this diagonal, then minus, start with this diagonal, diagonal, and this diagonal. Okay, so 1 minus 1 and to this, 1 minus lambda and to this, and 0 minus lambda and to this. And from this side, one minus 1 and to 0, 3 and to 1 and to 0, these two and to like this. Okay, solid. Minus 3. Why minus 3? This is nonsense. This is plus 3, sorry. This is plus 3. Okay, solving this with the help of calculator. So this is characteristic equation, and now we are going to solve it. So part B is solution. I told you that before. A minus lambda I, perhaps I could remember that I did not write determinant, so don't forget determinant. There is determinant. Now this is characteristic equation when you do it. So this is our characteristic equation. In the previous slide, I remember I just wrote A minus lambda I equals 0. So this is still matrix, but when we do determinant, we get this equation, and this equation is known as characteristic equation. Now we are solving it. So calculator, sorry for about this, 3 answers. So this time we have 3 values for eigen. Exercise. So now it's time for you. Practice them. If you have any problem, come online and kill your problem in my presence. Okay? See you. Good day.